So we've got a variety of strategies for evaluating analytic limits. We have to be able to decide which of those strategies we're going to use. So on Khan Academy, they give us a nice flowchart that helps with the strategy. Um, Unfortunately, I think this flowchart has some drawbacks. In particular, a lot of the things kind of blend together, and it's hard to tell what's what. So I've got an updated version of that flowchart that looks like this. Things are boxed in, so it's clear what belongs with what. And I also highlight three of these things here. So when we're using these flowcharts, these three boxes here that are highlighted in bright red are going to be our final ones. So whatever strategies we use here, we're going to end up with either option B, option C, or option H. So I want to talk about the flowchart here a little bit and talk about how we're going to use it. So we always start up here at the top with direct substitution. So we have a limit. We're given a limit problem. We want to evaluate a limit analytically. First thing we're going to do is we're just going to try to plug in a into f of x into the function and see what happens. So when we do that here, we're going to have one of three things happen. One of them is the probably the best case scenario. We just get a number. So we plug the value that x is approaching into f of x, and we get a number. That's our answer. If we don't get a number, it's going to be because we got zero in the denominator. And if you haven't had a chance to yet, watch my video on that, where we're selecting procedures for determining limits where zero's in the denominator. So there's two things that could happen there. We could get some number divided by zero. In that case, when we take a number that's not zero divided by a number that is zero, or at least really close to it, we're going to get really big values. So we get infinity or negative infinity, and that's where we get the asymptotes, at least asymptotes on the graph. If we get zero divided by zero, this is where we're going to have to do some manipulation. So we follow our flowchart here to this, and we've got a few different options depending on what the function looks like. So if we've got a rational function, which is a polynomial divided by a polynomial, we might do some factoring and canceling. If we have an expression that has a square root in it, particularly two terms where one of the terms is a square root in either the numerator or denominator, rationalizing with conjugates is going to be a good option. If we have something with trig functions in it, then using trig identities might be a good one. So changing tangents and cotangents and cosecants to sines and cosines might be a good strategy. We've got double angle formulas that you can look up if necessary. You've got the Pythagorean identity, but we can use some trig identities. Once we do that, we can do some canceling, and it says try evaluating the limit in the new form. So we've got a new form. So we go back to the beginning and we try direct substitution again. So on Khan Academy, when they're asking you what strategies we're going to use, if you say that you're going to use factoring, you're not done. So once you use factoring, you go back to the beginning, you're going to try direct substitution again, and then see what happens. If we get a number, then we're done. If we don't get a number, we still get zero in the denominator, we go somewhere else. All right, so again, when you're choosing your strategy, you're always going to end up with B, C, or let's say none of these strategies work here. So we have an indeterminate form, and we try factoring, we try conjugates, we try trig identities. None of that stuff works. That's where we might take a numeric approach, and we just plug in values close to a into the function, and we see if we can figure out what's going on. So this is where we would use a table of values, and we would use approximation. So H is also a final destination here. So just to take a fairly simple example, let's say we're doing the limit as x approaches 2 of x squared minus 4 over x minus 2. If we try direct substitution, okay, that's going to be our first choice. Always going to start there. We try plugging 2 in, we get 0 over 0. All right, so we get 0 over 0. That means we're on D. So this indeterminate form here, we've got three options, and with this particular function, factoring looks like a good option. So let's do that. Factor the numerator and factoring, and I should also point out factoring conjugates and trig identities also includes simplifying once you do those things. So simplifying here, we can cancel the x minus 2's. So our new limit is going to look like this. Let me update my list of things here. So I did factoring here, so I need to include E on my list now. So once I've done that, I go back to direct substitution. So I'm back on A, and I'm not done. So I'm going to try direct substitution. I plug the 2 in for X, and I get 4. So I've got a limit that I found, so I'm on C. Remember, B, C, and H, the ones that are highlighted in red, this is getting a little sloppy here, sorry about that, but the ones that are highlighted in red are always going to be the last one. All right, so make sure that you end on one of those where it says limit found, asymptote, or approximation. So when I'm doing a Khan Academy assignment, this is the list that I'm going to put in there, A, D, E, A, C. So make sure that you're always ending on one of those in red, always starting with direct substitution and then going from there.